Hi everyone, hopefully you're all doing well and staying safe. Hopefully it won't be too much long and lockdown will be over and we'll be able to resume our learning in the classroom as normal. So we're going to move on today. Last lesson we learned about the factors and what makes factors important. We found out that some numbers have an odd number of factors. And the reason for that is because it was the same number twice. So for example, number 16 was the same as 4 times 4. So it had only one number, 4, rather than 2, as in 1 and 16, as the factors. So some numbers had odd numbers. And we're going to look into those numbers a little bit more, odd factors. We're going to look into those numbers a little bit more today. So on the board, you can see that I've put in 4 numbers already. If we're going to be looking at squared and cubed numbers, first of all, it's really important we know what square and cubed are. Obviously, we know shapes, we know what a square is. So a square is a shape that has 4 equal sides and 4 equal angles. Probably not the best drawn square in the world, but it'll do. So what it means is that this side here is the same length as this side here, and that side there, and that side there. Okay. We've done area and perimeter as well. We're going to move on to that next time as well, because it's really important to have this knowledge before we move on to area and perimeter. But when we're looking at finding the area, what we do is we multiply one side by the other side. So that's exactly what squared numbers are. If I take the number, I'm going to look at 2 squared first of all. What I'm looking at is how many numbers I've got going across. So going across here, I have 2, and down here I have 2. If I were to draw this as an array, I would put 2 going across, 2 going down. Okay, so 2 squared is actually exactly the same as 2 times 2. It's the number times by itself. Okay, and the square numbers don't stop at 12, they keep going. You can have 157,000 times 157,000. That's the same as 157,000 squared. Not that we're ever going to need to use that in our lifetime, it's very unlikely that we will anyway. So 2 times 2. 2 squared equals 2 times 2. It's the same as 2 times 2. Same as 1 squared is the same as 1 times 1. You can see we've got 1 square going down, 1 square going across. How many squares do we have in total? Well, we have 1. 2 squares, 2 squares going across, 2 squares going down. How many squares do we have in total? 2 times 2, we have 4. 1, 2, 3, 4. Yeah, that's correct. So 3 squared. You can see here the notation for squared, the symbol for squared is you have the number and then the 2 is slightly smaller and in its top right corner. Okay, that is the symbol for squared. Okay, so rather than writing 2 times 2, 1 times 1, you would just write 2 squared. When we come to do things like algebra in year 6, when you move into year 7 in secondary school, you'll do a lot of algebraic equations which will involve these numbers here, which is squared numbers. So it's basically saving you a little bit of space. Okay, so 3 squared, I have 3 squares going down, I have 3 squares going across. My array is 3 times 3, which is 9. 4 squared, 4 going across, 4 going down. 4 times 4, we know our trick with our times tables, double it again. 4, 8, 16. Okay, and that is how we work out all of our squared numbers. All of these squared numbers up to 12 by 12 times 12 are all in the times tables that we need to learn. So it's really, really important that we know them, and we know them like this, because we can use these to help us really easily. So for example, if I wanted to know 7 times 8, I would know that 7 times 7 is 49, add another 7 gives me 56. So if I'm doing it in my head, that's how I would work it out. Okay, so knowing these key numbers and times tables gives you the opportunity to use what you know to work out questions that you might not know. Okay, so these are the square numbers. Your first task is to work out all of the squared numbers and write them down up to 12 times 12. You don't need to draw them out on like I have here. However, if you're struggling and you want to do count the squares, that's absolutely fine if you choose to draw an array and do that as well. Okay, so the way you could do it is you could write 1 squared equals 1. Down below, write 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 6 squared, all the way up to 12 squared. Okay, and it's really, really important that you do all of these now, because we're about to do cube numbers, and you'll need to use the, or if you have this information here, it's going to help you when we try to find out the cube numbers. Okay, so if you want to pause the video now, try and find all the squared numbers up to 12 by 12. Okay, so hopefully by now you have all figured out all of the squared numbers up to 12 by 12. If you haven't, pause the video now, go back and do it, because it's really important now we're moving on to cube numbers. So a cube number, if we imagine a cube is a three-dimensional square. Okay, we have to look at one of the faces of the cube. Okay, I'm going to draw it so it's going to be, same example earlier, 2. I know it's not very even. The angle I'm looking at it is, but it's pretty badly drawn. I apologise for that. I'm a good maths teacher, not so quite good with my artistic skills. So if we're looking at here 2 cubes, my notation for cubed is a 3 rather than a 2, and you'll see why in a moment. Okay, so this here, what I've drawn is 2 squared. It's 2 up, 2 across, and to make it cubed, to make it three-dimensional, okay, I would go 2 back. Okay, so if you were to find something that is roughly a cube shape, I'm trying to think if off the top of my head I've got anything here that I can use. I don't have a 2. I've got. It's not quite a cube, but you'll have to forgive me for that. We use this nice Kellogg's Crunchy Nut bowl. If you imagine that it's actually a square, it's not actually rectangular. If it's going 2 squares going down, 2 squares back, 2 squares across, and 2 squares back. Okay, it would look something like I've drawn on here. Okay, and the reason for this is when we're thinking of cubed, we're looking at 3 dimensions rather than 2 dimensions. Hence why we've got the 3 instead. When we worked out a cube number, it was 2 times 2. So if I look here, 2 times 2, a cube number is 2 times 2 times 2. So the notation of the 3 is because there's 3 lots of 2. 2 times 2 times 2. Okay, not 3 lots of, because that's the same as when you're multiplying. Yeah, it's 3, like you're timesing it by itself 3 times in total. So 2 times 2 times 2. And the reason is you've got 2 down and 2 across, and then we multiply it by 2 to get the width as well. So 2 times 2 is 4, times 2 again is 8. And what that is telling me now is if I were to get some square Lego bricks or some square Duplo or any of building things that we might have, I would need 8 cubes in total in order to build a 2 by 2 by 2 cube. Okay, so when we come to do things like shapes, when we come to do capacity, this kind of thing, this will be really, really important. Okay, so these are the same as, so things like 2 times 2 times 2 is 8. It's quite simple to work out. Okay, 1 cubed would be the same as 1 times 1 times 1. 1 times 1 I've already done, I know it's 1. 1 times 1 is 1. 2 times 2 is 4, because I've worked it out here. 4 times 2 is 8. If I was to now try to work out the 3 times 3, so imagine that this is a cube very expertly drawn by Mr. Bailey. There we go, a 3 by 3 cube. It would be the same as 3 times 3 times 3. Okay, this is now where it starts to get a little bit harder. 3 times 3 we know is 9. 9 times 3 we can do, we know it's 27. Okay, and from now on it starts to get even more difficult, because now we're looking at bigger numbers than what is in our times tables. So I'll give you one example. 4 times 4 times 4. 4 times 4, I can double it again, so 4 times 4 again is 8, times 4 again, 16. Now I've got 16 times 4. If I'm good at doubling, I can carry on doing my method of doubling again. If I'm not, or if I'm trying to do this in my head, it might be quite difficult. So this is where we come to use the written method that we did 2 or 3 videos ago. Okay, so 16, double it, 32, double it again, 64. However, if my knowledge of doubling isn't particularly strong, then I might find that a little bit more difficult. I'm going to give you an example now. So one of the things that I find quite difficult is when you've got things like the 7 times tables. So if I was trying to work out, I know it's slightly going sideways, 7 times 7 times 7. So 7 cubed is the same as or equals 7 times 7 times 7. Trying to do that in my head now without any working out of any jotting is going to be really, really difficult. So this is now, excuse me, when we go back and we use our skills of multiplication. 7 times 7 I can do in my head, I know that's 49. 49 times 7, well actually if I was clever I could round this up to 50, do 50 times 7, but it's still a lot of work. (49 times 7). Hopefully now some of you are going, oh yeah, I remember how to do that now. If not, if you're struggling with this, please go back, watch that video, come back to this as well. 9 multiplied by 7 is 63. Let's put 6 in a circle here. 4 times 7, well I can do same as 7 times 4. 7, 14, 28, add 6, gives me 34. So hopefully that's right. 49 times 7 would be 343. If I was to say 50 times 7, that'd be 350. Take away 1 lot of 7 is 7, 343. So 7 cubed would be the same as 343. And obviously if we look at going from 1, 8, the numbers are getting increasingly bigger. Okay, so you need to make sure that every single time you don't know if it's a big number that you can't do mentally, you have to use the written method. Okay, particularly when you get up to the likes of 12 times 12, 12 times 12, or 144 times 12, where you're going to have to do a very long method of multiplication here. Okay, so your task, can you find all of the cubed numbers up to 12 cubed? Okay, have fun with that. Tomorrow I'm going to upload a video looking at, I believe, area and perimeter. Okay, so hopefully you'll have fun with this, hopefully you're all staying safe and enjoy.